Hello, good morning. I'm Dr. T. Vikraman. I'm an associate professor working in the Department of Mechanical Engineering. I, I teach design of machine elements. The subject code is 15ME53C for the fifth semester students. In the first unit, the first unit, the caption is stresses, various stresses acting on the machine elements. There are two types of stresses. One is direct stress and another one is indirect or secondary stress. In a machine element, these two types of stresses are acting whenever external load is acting on them. Other than this, stresses are classified as tensile stress, compressive stress, bending stress, and shear stress. The tensile and compressive stresses are induced on the machine element because of the tensile force and compressive force acting on them. Say whenever the force is pointed away from the cross-sectional area, such stresses are identified as tensile stress, and the compressive stress is identified as the force is pointed towards the cross-sectional area. In case of tensile stress, the strain is positive because of the longitudinal strain, which is positive. Because the dimension increases along the axial direction, otherwise along the lateral direction the dimension decreases. In case of compressive stress, along the axial direction dimension decreases, but along the lateral direction dimension increases. Therefore, in case of compressive stress, strain is negative along the longitudinal direction. And the bending stress is induced because of the bending moment acting on a machine element. The bending stress is induced whenever a member is subject to an eccentric load or an eccentricity is induced because of axial misalignment. In most of the cases, the bending stress is induced because of the external load acting on them. Whenever a shaft is loaded, if the length of the shaft is too large, then bending stress is induced. Therefore, it is essential to estimate the magnitude of the bending stress. Apart from the bending stress, the shear stress is also an important stress component acting on a machine element. These stresses are induced whenever a twisting moment is induced on them. A torque or a twisting moment acting on a machine element such as shaft or a static or rotating shaft are subject to shear stresses. I have shown a simple diagram explaining the tensile stress and the compressive stress acting on a circular bar. Whenever a bar is subject to tensile force, the tensile stress is induced and the resultant strain is positive in nature, which is measured as a change in length divided by original length. So, as we know that the Hooke's law states that stress is directly proportional to strain within elastic limit. So, stress is indicated as sigma. Therefore, sigma is equal to capital E into small e. Here, the capital E term is identified as Young's modulus, and the small e term represents strain. So, the Young's modulus is an important mechanical property which is used for design calculations, is a measure of stiffness of a material. So we estimate ultimate tensile strength and tensile yield strength of a material by conducting tensile test. So in case of ultimate tensile strength, this property is not used for design calculations for a ductile material, but for brittle material, ultimate tensile strength is used for design calculations. In case of ductile materials, yield stress is used because a machine element made with ductile material should not be exposed to up to yield stress. Therefore, a safe stress is arrived at by incorporating a factor of safety value. Therefore, the factor of safety is estimated by finding out the ratio between the yield stress and the permissible stress value or the working stress. This ratio is an important one which is used as a measure for designing machine elements made with ductile material. In case of brittle material, ultimate stress is used for design calculations. Therefore, the factor of safety is the ratio between the ultimate stress and the permissible stress or working stress. Here in the second diagram, I have shown the development of shear stress on a metal forming process. Say in the sheets are subject to blanking force. So because of the applied blanking force, the shear stress is developed in the part. So there will be an unbalanced force acting on the along the circumference, which results in shearing of the part. So blanking and punching, all these operations involve in shearing of metal. So with this, we can estimate the forces required to blank, and the press capacity can be calculated. So once we know the material property like ultimate shear strength of the material and the shear area, then we can calculate the punch force or the press capacity. Okay. Now, I like to discuss about a machine element. Say a milling machine is having so many components in it, several machine elements in it. These elements are subject to various stresses. These stresses are developed because of the cutting force exerted by the multi-point cutting tool. In case of a milling machine, the tool is a multi-point cutting tool. The line contact exists between each cutting edge available in the cutting tool and the workpiece. Therefore, there are n number of cutting edges acting on the machine element. So the material removal rate is more in case of a milling machine, and the material removal rate is less in case of a single point cutting tool. The tool is subject to shear stress and compressive stresses. Also, the tool exerts compressive force on the arbor, a shaft which holds the tool. Therefore, at the center, a point load is acting. Because of the point load acting on the shaft, it bends. Apart from that, shear stresses are also developed on the machine on the shaft because of the shear stress, which acts in the opposite direction to the rotary motion of the shaft. Therefore, shearing of the shaft may take place because of the induced shear stress. When the induced shear stress exceeds the permissible limit or the maximum shear strength of the material with which the shaft is made, failure takes place. Therefore, it is essential to design the shaft safely, otherwise failure may take place. So in the other machine element, say the work welding device, which is also exposed to severe stresses. Therefore, it is essential to take care of all the stresses acting on the machine element. I have shown a milling machine with the various machine elements fitted with it. So on the left side of the diagram, I have presented the machine element, important machine column, which houses the transmission system comprising of the motor, pulley, and belt transmission system. And this belt transmission system in turn is connected to a gear transmission system where few number of gears are integrated. An intermediate shaft is also provided between the input and output shafts of the gearbox. The output shaft in turn is connected to the arbor, which is supported at both ends with bearings. The bearings, they have a roller bearing and a thrust bearing, so that axial force can be withstood which is taken care. So at the center of the shaft, the tool is fixed. The power is provided to the shaft through the ears, and the shear force exerted on the workpiece removes the material, which is shown in the diagram.